Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Shaufi bin Muhammad Sharif with metric number D052010 and 115. Today I want to show you how to make a pneumatic circuit, which is a fail-safe circuit, and what is the function of the component. I will tell you guys what is the function of for each component, and I will tell you the function of the circuit in real life. So let's start. Okay, first of all, before we need to pick for each component, which is I pick a tank. I pick 5 tank, and for the function of tank is to provide temporary storage for compressed air, and then I will pick fixed displacement pump, and the function is a fixed displacement pump is a positive displacement type where the amount of displacement cannot be varied only by changing the drive speed to the pump. After that, I will pick a filter, which is the function for filter is the filter clean compressed air and traps solid particle. And then after that, I will pick double acting cylinder, which is the function is double acting cylinder is a one where the thrust or output force is developed in both ascending and retracting direction. And then we will pick two-way valve with manual and spring return, and the function is pneumatic application where the supply of air must periodically be closed off. And after that, we will pick three-way valve with push button and spring return, and the function is to control a single action cylinder driving pneumatic actuator, blow off, pressure release, and vacuum application. And after that, we will pick four-way valve with pilot, external supply, and spring return, which is the function is to supply pressure to one side of the cylinder while bending the opposite side out as moved here. Okay, after that I will move it faster. Okay, back to this. Okay, after we have picked 4 two-way valve with pilot, external supply, and spring return, we will pick okay. After that, we will pick counteracting valve 2. We need 2 counteracting valve, which is the function is to allow for safe control of compressed air in pneumatic application, which is also this shut-off valve. And lastly, we need to pick check valve, which is the function is to allow the flow of air in and prevent it from going out. Okay, after we have collect all the component and put it in the white canvas, we need to arrange them into the proper position. I will move it forward. Okay, after I have arranged it into the position that you want, we need to connect all of each component with a wire. Okay, this is where I arrange it and connect all the components with wire. Okay, this is when you have connect all the wire. This is the complete circuit for fail-safe circuit. Okay, let's move to the result. Okay, this is the complete circuit that we have arranged and connect all the components with wire. Okay, so before we going to start this circuit, we need to press the play button icon on the right, on the up. So when you have pressed the play button, you will see the air will flow through the wire. Here you will see the air flow through the wire and go to 4-way valve and direct into the double acting cylinder, and the double acting cylinder will move forward. Okay, when you change the position of 4-way double acting cylinder, it will move it forward because the airflow will move through it. Okay, after you change the position of 4-way valve into the right hand side, you will see the double acting cylinder will move to the original position because the air have been going out from there and move to the 2-way valve. Okay, that's all for the observation. Okay, for this circuit can be applied on real life in an elevator system. Okay. As you can see, fail-safe device or system are not meant to prevent accident or failure from occurring. Instead, they are put in place for when things to go wrong. Fail-safe are built with the expectation that failure situation will eventually happen. They prevent unsafe consequences when failure does occur. Fail-safe system can range from mechanical and physical to electronic or electronic depending on the system or device. Okay, for example, elevator have several set of emergency brake that come into effect in the event of a breakdown of power failure. Should the elevator malfunction or begin to fall, then the brakes will activate and stop the elevator from falling, or slow the fall to help keep passenger relatively safe. This would be an example of a mechanical fail-safe system. That's all for me. Okay, thank you.